Hello, we're talking about our log applications worksheet today. And before we do that though, I would suggest, very highly suggest, that you check the PowerPoint for the log applications and the formula. You should, after you've done that, be aware of these four formulas. A is equal to P 1 plus R over N to the NT, and also A equals to PE to the RT. And then R equals natural log of 2 over T, and T equals natural log of 2 over R. The first one, P parentheses 1 plus R over N to the NT, is our periodic compounding formula. Periodic compounding formula. The second one is our continuous compounding. It's called the PERT formula, A equals to PE to the RT. And the last two there are derived from that PERT formula. These are the continuous doubling or continuous halving for the rate and also for the time. So if you're told that how long will it take for something to double continuously, you can use this formula. Or if you just want to know what the rate is for doubling continuously, you can use either of those two formulas. One involves the rate, the R, and the other involves the T, the time. And we'll discuss those when we get to the problems. But most important that you look at the PowerPoint. I've tried to give a voiceover too. I'm not sure whether the Canvas will pick that up or not. I'll try to get it to you one way or the other. If I can't get the voiceover, at least you can watch the slides, which are very instructive. But you'll need those two formulas. Now, we're going to do the odd ones together here. And I have at the top here, first of all, what I've had at the top forever, it seems, a log's an exponent. We need to remember that, okay? And then secondly, we're going to always consider whether we're talking about periodic or continuous. If we're talking about periodic compounding, we'll be looking at the first one. If we're talking about continuous, that'll be the next three here. Okay, periodic versus continuous. And maybe I'll just do a big P out here for periodic. And continuous. Periodic and continuous. Number one, and you'll again have to probably download the sheets from your, unfortunately again, another packet I had intended to give you but couldn't. You have to download the sheets for the logarithmic applications worksheets. It's there on the files in Canvas, so download those please. There are probably a few pages there, maybe 3 or 4 for you to do. The answers are there too, okay, so you can check the answers as you're going along. Number one says, to find the time for the prices in the economy to double using annual compounding, the periodic compounding if you would, if the annual inflation rate is 2%, 4%, 6%, and then round that to the nearest 10. There are 3 different problems here. Let's take the first one. We want to find out how long it takes for the price in the economy to double if we're compounding annually here. I use the periodic compounding here, A equals to P 1 plus R over N to the NT. We want to talk about doubling. So I change the A to, if I'm starting with P, maybe twice that. I want to end with twice that. And then of course if you cancel or reduce or cross out and divide by P on both sides, you'll be left with this. And then meanwhile, I change the rate which was given 2% to 0.02. And we're told that this is annual, so the ends are 1 here, the number of times per year, 1. And basically we're looking at this then, 2 is equal to 1.02 to the t. At that point we can now, as we saw previously, you can go ahead and take the log of both sides so you get the t down to base level, or the natural log. I like to use the natural log because that's going to be kind of useful for us later on. So let's take the natural log of both sides, which gives us a natural log of 2 equals a natural log of 1.02 to the t. You know the t should come forward here, and we'll be looking at the t out front. And to get t by itself, let's divide both sides by a natural log of 1.02. So we're looking at this, t is equal to natural log of 2 over natural log of 1.02. Be careful at this point. You want to use your log tables now, but be careful to use the proper log tables, okay? Whether using, if you want to use, say, common logs, you can use the common log tables. I'm using the natural log tables, which is the second portion here, okay? So the natural log tables, a natural log of 2, you should find here as 0.693. And the natural log of 1.02, 1.0 and then 2 across should be 0.020. Basically 0.02. If you divide that, you should get 34.7 years there. So if you're looking at annual compounding here at 2%, it'll take you 34.7 years to double your money there. Now part B says 4%. Well, there's no reason to go through everything again. If it's 4%, we're just going to change this 2 to a 4, that's all. And in fact, that 2 will become a 4 throughout here. Instead of the 2 here, a 4 also. And instead of the 2 there, a 4. And also here. And basically what we're looking for then is, we're looking for the natural log of 2 divided by the natural log of 1.04. If you look for the natural log of 1.04, you'll find it's 0.039. So I'm going to change that to 0.039. And then I really wouldn't expect you to divide that. What I expect you to do is to round that. In other words, 0.039 is close enough to 0.04 to do that, okay? So I ask you to round that maybe to 0.04, okay? And then do that division. With that division, I'm looking at about 17.8 or so in the answer here. So 17.8 should be a nice answer for us for part B, okay? And then for part C, I have it listed over here. 1.06 is 0.058. So just replace the 1.04 with the 1.06 throughout. And then when you get to 1.06 here, change that to, instead of 0.04, 0.058. And then maybe you want to just make that 0.06 also. And I get about 11.9 years on that, okay? So that's number 1 for us. It's using the proper formula, and then after you use the proper formula, inserting the data, and then trying to get the t down to base level by taking the natural log or the log of both sides. Once you've done that, you get t by itself, find the, by way of the tables, the various numbers there, and then proceed to divide those, simplify a bit, get a good answer. Now number 3 is the same problem, believe it or not. All I did was added a lot of words to it to make it look like it's more difficult, but it's really the same thing. Number 3 says Sarah Smart Saver invests $15,000 in an account paying 7% interest compounded annually. It doesn't say compounded continuously, so it's an annual compounding here, like periodic compounding. How many years will be required for the compounded amount to double? Basically, we're going to be using this same situation right here. But let's go through it anyhow. If we use this formula, A equals to P 1 plus R over N to the NT, we want to begin with 15,000, as Sarah does, and she wants to double that. So that's why 30,000 is used here. The rate she's getting is 7%, that's 0.07 here, and we're doing this for 1 year at compounding, so a 1 there for the ends. Basically, when you divide both sides by 15,000 here, you're left with 2 is equal to 1.07t. Take a look just opposite that. Looks kind of the same, doesn't it? The same situation. Whether we talk about the values here or not, when we're doubling something, that's going to be a 2 here. No matter what number you put here, double that, and when you divide, you get a 2. So it's really the same problem. I take the natural log of both sides again. I've done that in this particular step. And then divide by natural log of 1.07 here. That'll be natural log of 2 divided by natural log of 1.07. Natural log of 2 we'll get to know is 0.693. Look at the table, 1.07 for natural log. That's again the natural log table here. And look for 1.07. It's 1.0 across the top and all the way over here to 7. And that looks like 0.068. And when you do that division, that should be 10.2 years, okay? So basically a similar type problem, same type problem basically. Instead of making it very brief as I did in number 1, added a few words to it, made it sound like it's more difficult, not so at all, the same problem. And number 5 is not that way. Number 5 will take a bit of time, and it's a bit involved, but we can do it. And it's probably about maybe the most difficult on the page. But we'll go through it step by step, and after that it might be smooth sailing from there. But it will take a bit of time. You might be reading that while I'm erasing this just to get a general feeling for it. And the first thing you want to do is consider, are we talking about continuous compounding or are we talking about periodic compounding? That'll make a difference as to which formula we use. If you're using the wrong formula, it wasting your time. So check to see which formula we should be using. And then after that, we'll write that formula down and fill in some data. And then maybe proceed to get a good answer here for this. Number 5 says a couple wants to have $50,000 in 5 years for a down payment on a house. How much should they deposit today at 4% compounded quarterly to have $50,000 in 5 years? And then, as a second question to that, how much interest will they have earned at that situation? Okay, it doesn't say anything about continuous. I'm going to go ahead and use the periodic compounding for number 5. Now that's going to be A is equal to P 1 plus R over N to the NT. The principal, it says how much they want to have 50,000. That's not P. They want to end with 50,000. So that's the A here. A is 50,000. How much must they invest? Don't know that. That's P. And then 1 plus R. R, the rate we're getting on this, we're told is for number 5. It looks like we're talking about 4%. 0.04. And that's compounded quarterly, so be careful. Compounded quarterly means 4 times a year. Kind of odd, it's 4 times a year, but it's every 3 months, okay? Nonetheless, it's a 4 there for that. And then the same thing for the n. Same thing for the n here as the exponent, 4 there also. And a t, we know the t in this case, it says how much after 5 years. So we're going to put a 5 there for the t, okay? T should be 5. So what we're looking at is this. We're looking at 50,000 is equal to P 1.01 to the 20th power. Okay? 1.01 to the 20th power. That's not 20 times 1.01. It's 1.01 multiplied 20 times. It's really tough to do. Probably with a calculator if you knew the right functions at play to use, okay? We're going to do it without a calculator. We're going to go over here and say, what is that 1.01 to the 20th? Don't know. So I'm going to say, call that x. X is 1.01 to the 20th. I'm going to take the log of both sides. In fact, probably just, in this case, probably natural log of both sides. Just try that, okay? Let's take the natural log of both sides. That might be easier for us. The natural log of x equals to natural log of 1.01 to the 20th. You know that 20 is going to come forward. I'll keep the natural log of x here. And that's equal to the natural log of 20. In fact, 20 times the natural log of 1.01. Let's look for the natural log of 1.01 on our table. Our table, again, natural log table is the second table here. And the second one back there, 1.01, looks like that might be 0.010, okay? 0.010. So we replace this natural log of 1.01, 0.010. And that's natural log of x equal to that. And then when you multiply that by 20, you should get the natural log of x is equal to, how about 0.20? That sound okay? And what we have then is not natural log of 0.20. We have the natural log of x equals to 0.20. What we like to do is we like to say, look, what number here has a natural log of 0.20? Well, let's go to our table and let's take a look. The natural log of 0.20, we may not find it in the table, but maybe we'll come close. We're going to look in the maze of our table, not out here. This would be the natural log of 1 point whatever. That's if we had x. This time we are looking for something in here in the maze to find out what x is. So 0.02 for the natural log. 0.0 for the natural log looks very close to 1.22. I'm looking at 1.22 as 0.199. 0.199. I think that'll round off very nicely to 0.2, won't it? So let's use that. Let's use that as, again, we'll use that as 1.999. 1.999 and go across, you'll see 1.2, and go up, you'll see 2. So basically, the natural log of 1.22. Natural log of 1.22 should equal to 0.20, actually 0.199. Okay, so we look across and up and find that's the answer. So that it turns out that x is now equal to 1.22. We called x 1.01 to the 20th. Let's go back here and replace then that 1.01 to the 20th with 1.22. 1.22, that's equal to 50,000. The last step would be to divide by 1.22. And hopefully, if we do a good job with the division there, that should give us maybe 40,984. 40,984. That's what we have to insert now, or it's what the couple has to insert now. 40,984 to get 50,000 when they're finished. To find out what the interest rate is, let's just subtract these two. If they insert this and end with 50,000, then we'll subtract those two, and the interest that we've earned from this is going to be then the difference of those two, and that should be hopefully a matter of 9,016. Okay, so $9,016 should be the other part of that. Okay, these are our two answers then, 40,984 and 9,016.